Welcome. So today we're going to go deep on a topic you probably think you already know inside and out. Operators. These are the fundamental verbs of JavaScript, right? The little symbols like plus and minus that make your code actually do stuff. But as we're about to see, some of them have some hidden complexities that can lead to some, well, pretty surprising results. Let's get into it. Okay, right off the bat, let's just start with a puzzle. You look at this code and your brain is probably screaming the answer should be 5 or maybe 14. But no, JavaScript gives you 122. Why? Stick around, because by the end of this, the logic behind this is going to be perfectly clear. So to solve that mystery, we really need to understand how JavaScript thinks about these operations. And that starts with some basic terminology that's going to lay the foundation for everything else we're going to cover. First up, operand. Now it sounds all technical, but it's actually really simple. An operand is just the thing or things that an operator works on. So in 5 times 2, a multiplication operator has 2 operands, the 5 and the 2. That's it. Now, some operators only need one thing to work on. And when an operator has a single operand like this, we call it unary. A perfect example is the minus sign when you use it to make a number negative. In negative x, the operator isn't subtracting, it's just flipping the sign of x. One operator, one operand. And if unary means 1, well, you can probably guess what binary means. Yup, it's an operator with 2 operands. That very same minus symbol in y minus x is now a binary operator because it's working on both y and x to perform subtraction. And honestly, most operators you already know are binary. Okay, so you definitely know the first 4 operators on this list inside and out. But in JavaScript, we get a couple of extra handy tools for our math kit. Let's take a look at the two you might not have seen before: remainder and exponentiation. The remainder operator, which is sometimes called modulo, looks like a percent sign, but it has absolutely nothing to do with percentages. It just gives you what's left over after a division. So if you have 8% 3, you're basically asking how many times does 3 go into 8? Well, twice, which is 6. And what's left over? The remainder is 2. The exponentiation operator is even simpler. It's just a handy shortcut for raising a number to a power. So instead of writing out complex math functions, you can just write 2 square square 3. This is just JavaScript's way of saying 2 to the power of 3, which of course gives us 8. Alright, with those basics covered, let's get back to our main suspect, the plus sign. You see, this operator leads a kind of double life, and understanding its two identities is the key to solving our initial puzzle. And this slide illustrates its two faces perfectly. On the left, it's the addition operator we all know from math class. But on the right, when you use it with strings, which are really just pieces of text, it doesn't add, it joins them. This is called concatenation, where it just chains the text together into a single longer string. So here it is. The crucial point is right here on this slide. This is the one rule you have to remember. If the plus operator sees a string on either side of it, it completely stops thinking about math. It just assumes you want to join things, and it will convert the other operand into a string to make that happen. Okay, let's apply that rule and solve our puzzle. JavaScript evaluates from left to right. So first, it sees 1 plus 2. Because that 1 is a string, our big rule kicks in. JavaScript converts the number 2 into the string 2. The result is the string 1, 2. Now it takes that result and adds the next 2. But since 1, 2 is a string, the same rule applies. The number 2 becomes the string 2, and they get joined together to form our final, surprising result, 1, 2, 2. Okay, so you see how that works. But what if we just change the order? I mean, does it really make a difference? Let's take a look at what happens when the string is at the end of the line instead of at the beginning. And yep, order matters a lot. Again, going left to right, the first operation is 2 plus 2. Both are numbers, so JavaScript just does the math and gets the number 4. Then it moves to the next operation, 4 plus 1. Now it sees a string. So the string rule kicks in, the number 4 gets converted to the string 4, and the final result is 41, a completely different outcome. Just when you thought you had the plus sign figured out, there's one more secret. It also has a unary form. When you put a plus sign in front of a single value, it doesn't add anything. Instead, it does something incredibly useful. It tries its best to convert that value into a number. So why is this so important? This slide shows a classic real-world scenario. When you get input from a user on a web page, it almost always comes in as a string. So if you just add the string 2 and the string 3, you get 23, which is definitely not what you want. But look at the right side. By placing that unary plus in front of each value, we tell JavaScript to convert them to numbers first. Only then does the binary plus do its job, giving us the correct mathematical answer, 5. That last example brings up an important question. How did JavaScript know to do the unary plus conversion before the addition? The answer lies in something called precedence, which is basically the official rulebook for the order of operations. Don't worry, you don't need to memorize this whole table. Just focus on the precedence numbers. The operator with the higher number goes first. As you can see, the unary plus has a precedence of 14, while the binary addition operator is way down at 11. That's the rulebook in action. JavaScript handles those unary conversions before it even thinks about doing the addition. Now that we understand the rules, let's look at a few shortcuts that pro developers use to write cleaner, more concise code. These are operators that modify a variable's value directly. It is so common to perform an operation on a variable and then save the result right back into that same variable, like n equals n plus 5. These modify in-place operators like plus equals and times equals are just shorthand for this. They do the exact same thing but with less typing. It's a small change that makes code much quicker to read. And the most common shortcuts of all are increment and decrement. Adding or subtracting 1 is something you do constantly in programming, especially in loops. So instead of writing counter equals counter plus 1, you can just write counter plus plus. It's quick, it's clean, and it's universally understood. But here's one final really crucial detail. The placement of that plus plus matters. Let's assume a variable counter starts at the value of 1. If you use the prefix form plus plus counter, it first increments the value to 2, and then it returns that new value, so the result is 2. But if you use the postfix form counter plus plus, it returns the original value first, which is 1, and then it increments counter to 2 behind the scenes. It's a subtle but powerful difference that often trips up new developers. So, let's bring this all home. What started as a simple math puzzle about the plus sign has really revealed a whole system of rules. You should think of operators not just as math symbols, but as the fundamental grammar of the language. We've seen how the plus sign leads a triple life, how precedence dictates the order of operations, and how even a simple plus plus has a hidden complexity. You're now equipped to look at your code and understand not just what it does, but why it does it. So the final question is for you. What strange bug or confusing line of code in your own projects now suddenly makes perfect sense?